Hello, my name is Mark.
I'm Aiden.
I'm Nielsen.
And I'm Liam.
And for this video assignment, we have decided to discuss how statistical analysis can help to predict traffic flow on roads given certain conditions. As engineers, we not only learn how to analyze and solve problems, but how to solve those problems efficiently. While it is important to be competent in your particular field of study, it is also valuable to have other skills that can be utilized to increase efficiency in another respect. For example, with the knowledge of statistics at our fingertips, we can make a proposal to our bosses that may result in more efficient traffic flow. Common methods that predict traffic flow used by the US Department of Transportation are the 90 to 95% travel times, the buffer index, the planning time index, and the frequency of congestion. Both the buffer index and the planning time index are adjusted from the average travel time to communicate the increase or decrease in travel time. These indexes are calculated for 90 to 95% accuracy. This sounds an awful lot like the utilization of confidence intervals. The computation of these indexes is not what is relevant to this project. However, the way in which we find these numbers are. All of the listed indexes are dependent on the concepts of variation, standard deviation, skew, and travel time distribution. The mean is not often considered when determining traffic flow due to the number of conditions that could drastically change conditions. Some of these conditions include time of day of the week, weather conditions, and gas prices. Concepts like variance and standard deviation help to assist the mean conditions with accurate or predictable analysis. When the results are tabulated, the skew and width of travel time distribution become apparent. According to those numbers, one could choose an index to calculate to closely predict traffic flow.
For an example of traffic flow using interval estimates and hypothesis testing, suppose there is a two-lane rural highway and a traffic engineer is looking for a mean spot speed. The engineer would use a multiple linear regression formula derived from a multivariate analysis of the highway. In this situation, the engineer would take into account the percentage of out-of-state cars, the percentage of trucks with one or more trailers, the curvature of the highway, the stopping sight distance, the lane width, the number of commercial roadside establishments, and the total traffic volume. For an example to show how mean, median, variance, and standard deviation indicate traffic flow, suppose an engineer wants to evaluate a certain route from A to B and collects data on travel time. The standard deviation of the data would indicate whether the route is reliable when nothing affects travel time. When something does affect travel time, like rain or an accident, the standard deviation would increase, meaning that travel time and unreliability increases. As the variance of the travel time increases, so does the mean.
Predicting traffic flow is critical because it allows us to monitor the routes we travel every day in real time. We have a better grasp of this notion. We must look at statistics and how they may be utilized to predict traffic flow. The terms variance and standard deviation are often used in statistics to describe the measurements of spread across a data set. Similarly, in the transportation industry, variance and standard deviation are used to indicate how spread out travel time patterns are. These principles are important since they will help with the indexes like BTI and PTI. When a problem occurs, such an unexpected weather event or a car accident is likely to cause traffic congestion, increasing the standard deviation of travel time. I-4 is an example of this. When I-4 was first constructed, traffic was there 24 hours a day, 7 days a week. Skew and width, like variance and standard deviation, are taken into account when estimating traffic flow. Skew and width also function together. For example, when there is a large amount of traffic, the distribution is heavily skewed to the right and wider. The wider the distribution, the longer the travel time, and the lower the travel time, sorry, reliability. I can say that. Um, the distributions are opposites when there's no heavy traffic. Skew and width assist in the solutions of traffic congestion by predicting the distribution of travel time given certain conditions.
One easy way to see the value of this information is by looking at how timed stoplights are programmed. It would be inefficient and pretty annoying if lights remain green for too long, for very idle roads, or if they were red for busier roads causing major backups. An efficient traffic light, on the other hand, is programmed to adjust to the time of the day. This is the result of statistical analysis of a given road at all times of the day for an extended period of time. So there is a sufficient sample size for what is considered average flow. This will give a better representation of outliers as well, showing the engineer how circumstances will not skew the data too much. As a positive, the implementation of these statistical concepts in theory would create a seamless traffic flow for most days of the year. Downsides of this is that these concepts are geared towards what is normal. So the statistical implementation of these lights, like on Christmas Day, where traffic is different from the norm, will not be very accurate or dependable. There are many things to consider, and there's no perfect solution, but the concepts make life on the road just a little bit easier for everyone.